Then we have a producer, which is kind of a person which guides the overall production quality or aesthetics of a game. And then there is the sales team and the analytics team, which kind of drives the overall business of the game development team. So there are various other team members as well, like a game journalist, a game copywriter, and all of those. But this is like the core kind of a structure for any game development team. Now, what happens typically is when any young programmer or any young person comes and tells me that they want to come into the games development, they say that I like playing games, I like playing PUBG, I like playing FIFA, Valorant, and all of that, and I can be a good game developer. I always tell that person is first try to understand what is it to mean to make a game, because it's very complicated to develop a game. It is not, playing games is one thing and developing games is a completely different thing. So yes, if you're a good gamer, you can make better games, but it's not necessary. I have many game developers who are really bad gamers, and I have some brilliant gamers who are not so good game developers, and that's why they stayed more on the game testing, game compliance side of things, not into the game development programming side of things. So there is no direct correlation between whether you are a terrific gamer and a terrific game developer, but yes, sometimes it can help. And in India, I think the biggest challenge for us is there are a lot of youngsters and a lot of young people who have a very good game idea, but they don't know how to take that game idea to an actual release and make it a profitable business. Because a lot of people come up with a game idea and they kind of make an Android game and release it, but the game doesn't make any money, only it's used to show your friends, okay, I've released a game, or this is a good prototype, or you show on your LinkedIn profile that, okay, I've made a game. But for you to kind of, if you want to get into the business of developing games for yourself and creating your own business, then you need to understand the whole process. So when you're creating a game IP, the process involves from going from a game idea, then a game designer would document it. A programmer can also do that if the programmer has some creative outburst. So you'll outline the game design, then you will implement it. We'll go into that in more detail into this lecture as to what are the decisions you take on an architecture level. So you would implement the game. Then the game testing division would find the bugs, and then you would fix the bugs, and then they'll find more bugs, and that process continues. Then you will have your production release. And for most people, this is where it ends. But actually for the game development business, this is where it begins. Because this is where the game or the product that you're making is actually going out into the market, where people are playing the games, where people are going to play it and then realize, okay, I don't like this, I like this. And then based on that analytics, you have to continuously give support to the game and give a live operations. What does live operations mean is basically you are, after a production release has happened, you are still building features, you're still building modules, you're still fixing bugs, and you're still releasing it. And this process has to continue for a good game. You cannot just make a game, release it, and then you've forgotten about the game. And even this process is very important that the developers create a scalable architecture so that this process can happen. Otherwise, what happens is, let's say you release a game and there is a certain module that the users don't like. They're like, ye bekar hai, I don't like this. And the designer and the producer would come back to you and say that, ye to acha nahi tha, we need to change it. If the developer at that point says that, okay, to change this, I need to rewrite my whole code, I need to redo everything, then you have not created a scalable and flexible architecture to begin with. Because if your architecture is so coupled that to change a certain module or to change a certain feature in your game, you have to rewrite a lot of your code, then it's not written well at all. And that is where it's very important that from a game programmer perspective, that you think of the architecture from a very early stage. Because game design will change during the process, game design will change in bits and pieces after the game is released. So it's very important that architecture is thought of in a very early stage. And yes, when this entire process is complete and your game makes money as well, then okay, you have landed yourself a good game IP, which you can then transfer to a business model. Okay. Now, how do you decide on the game architecture? So when you're deciding on the game architecture, the first thing that you need to think of is what are my main core modules in the game. We'll go into game examples in the next few slides, but what are my core modules? And that is where a programmer should write down, this is my core module. Next point is very important, which I think most programmers suffer in the next point, is where or how the data will be transferred between these modules. Because what happens is you write your code, the game works, the product works, and a new feature is added. Now the new feature would require certain functionality or certain data from a certain module. At that point, what you would do is start writing spaghetti code. If your code is not written well, you're going to write singleton classes or manager classes, which gives global public access to everything, and then those public access data will be coming in, which is not the right thing to do. Because the whole concept of object-oriented programming, encapsulation, security is still valid, even though you're creating a new module, right? So data communication is extremely important if your game is building up and scaling up to a large game. Let's say an example, I think a game which most of you would have heard, a game like PUBG or FIFA or Free Fire, or even games like Candy Crush. Those games are not games which are made and after a year the game has stopped and you've forgotten about it and the developers have created a new game. No, the game has been going on 5 years, 6 years. The PUBG mobile is there, but the PUBG PC version is even older. So if you have to sustain a game for 5, 6, 7 years, let's say, your architecture should be written in a way that as and when new features are added, as and when SDKs are updated, as and when new like C++ or C# .NET frameworks are also updated, your code doesn't break. Your code still allows the data communication between those modules, right? Now the next question is, if it's a multiplayer game, what happens? Again, you need to think of how the communication will be between the client server. Fourth point would be to deciding on the game engine that you're going to be using. Now, most cases in game development, we would not use like raw native code. Like we would not in typical cases write native Java code for an Android game. We'll use a game engine, like a cross-platform engine, like Unity or Unreal. And if you're using Unity, C# would be your preferred language. If you're using Unreal, C++ would be your preferred language. So you need to choose your game engine based on your preference. Again, something that I get asked very often is, what game engine is good? Is Unreal better than Unity? Is that game engine better in all sense? Well, it's not true. It just depends on what you are more capable of. If your strong point is C# .NET, there is no point in choosing Unreal and C++, because you have to still go through that steep learning curve of learning C++, and you may not be good in C++ anyways. So why choose Unreal, right? Similarly, if you're good in Unreal, if you're good with C++, why choose a game engine which is C# oriented? So it is based on your strength rather than what the game demands, because in the current moment, both the game engines are equally capable. They can do a lot of good work if you have the capacity to do that. Now, the last 3 points are where game development becomes very different from a typical IT setup. Is because in game development, if you are making a 2D game or a 3D game, we now have a lot of artists. Now, artists could be 2D artists, 3D artists, animators, riggers, anyone. So you need to understand, let's say somebody has created a model in Maya or a model in 3ds Max, how to get that model inside your game so that you can use that game. So we'll go into a game engine. I'll give you a live demo of a game engine and how it works. But just to understand, the art pipeline is very, very important in games, because you need to decide, again, from an architecture point of view, how will you import those art assets inside your engine? What are the budgets that you're going to go with? When I say draw call budget, this is not a monetary budget like in money, but draw call budgets just means what would be the total number of triangle count of a model, like if it's 3D. Because if you make a really good looking game, but the game runs really slowly on most machines or your mobile, you will not play the game. No chance. Like if PUBG looked the way PUBG looks, or Call of Duty Mobile or Call of Duty PC looks like they looked, but they only worked in mobile phones which have more than 6 GB, 7 GB RAM, those games would not have worked. Those games work because on an architectural level, it checks what kind of architecture the mobile is using, and based on that, certain art packages are swapped out or optimized on the fly. And that is why you will get a very smooth experience on the lower end phones as well. It's not a very easy thing to do, but that is something that you need to do if you have to support this long range of users. Now here, before I go on to the next slide, you have to remember another mistake which programmers do is when they make a game for PC, Windows. Because most gamers would have a really high-end PC, people forget about optimization and they release a game, and let's say the game works, that is where they end up in trouble. Because if the game works, the publisher would say, let's release the game on mobile as well. Let's release the game on console as well. But the game, because it has not been optimized and architecturally not thought about, it is very difficult then to translate that game from a PC game to a mobile game, or a PC game to a console game, because there has been no optimization done in code. So on Windows PC, if you make any game with almost no optimization, it will technically work, because most gamers would have 32 GB or 64 GB RAM. They would have an RTX 3080 graphics card, so it will not matter. It only matters when you are developing that game onto, let's say, a Nintendo Switch, or let's say a PS4 or a PS5 or an Xbox or mobile. You need a lot of optimizations, because those are still not as powerful as a powerful gamer PC machine. So that is why it's very, very important. And the last part of the point is creating sandbox level. I'll show you what a sandbox level looks like so that it's better. I'll give you a live demo at that point. Now let's take an example of a shooting game, okay? Now, if you are making a shooting game, like let's say a PUBG or a Quake, right? How would you like write the scripts, right? Let's say a very basic script. Most cases, what developers would do, they would create one script called a player script, or player.cpp or player.cs. If it's Java, player.java, and write all the code into that one single monolithic class. Now there are multiple problems. When the game is small, okay, it doesn't matter, it will work. But the problem is, as the game keeps on growing, you will keep on adding functions into that one class, and then debugging becomes very difficult. Any kind of optimization becomes very difficult, and it's very difficult to maintain as well. All of these. So if I'm creating a shooting game, I will have my input script, my movement script, my shooting script, my collision script, my scoring script, all in separate classes. And there could be a central class which kind of talks to all of these classes, right? There could be a player script. There can still be a player script which talks to the input script, which talks to the movement script, which talks to the shooting script, collision script, and the scoring script. But I will not maintain one player script which has a monolithic class of everything combined, right? Because it's very difficult to maintain. And this is actually part of something known as a solid principle. I'll write it in chat so that you are aware what I'm talking of. So solid principle, I'll not go into depth of solid principle because it's a very standard principle. So I'm sure you might either read on Google, or there are multiple YouTube videos, or your college itself might teach. Now, in one of those points of solid principle says single ownership, which means one script should do only one thing. If it's an input script, the input script does not have to worry about how the character will move. The input script's only responsibility should be that I am taking an input from the user, space bar, backspace, A button, B button, and just registering that input. Movement script's responsibility should be just moving the character based on the input. So it doesn't care about what input it has given. That is a responsibility of the input script. The movement script's responsibility should just be moving forward, backward, sideways, and all of that. Same for shooting, same for collision, same for scoring. And this is a fundamental principle of solid principle, in which basically you split out your script into multiple scripts, and then each of the scripts has their own responsibility basically. Now, when you are passing data between these core modules, some considerations again, what you need to think about is, will we create a central structure, like, which is a common practice again by most programmers, in creating stuff like managers, which I am not a very big fan of, but okay, I understand why people create it. So things like game manager, sound manager, audio manager, level manager. The biggest problem when you're creating something with managers, and this is something that was told to me a long time back when I was interning in Microsoft for a very small period of time, where they told me that if you're creating managers, the two words which he told me at that point, my boss, my technical lead, that if you name a script called manager and if you name a script called controller, eventually those things will become monolithic classes. Because in your head, you will be thinking, okay, this is a manager, it should manage this. Okay, maybe this is also the part of the manager class. Same thing for a controller. If you name something called controller, chances are that psychologically you might think that the controller should control everything and will put everything in that class. I still see programmers doing that, but okay, I don't mind the naming conventions, but you have to be a bit careful that you do not hold everything in one monolithic classes. You have to split it down. And as programming is improving, like from the time, let's say in 2003, right about when I did kind of professional coding, till now, I think few things have changed. Now, more importance is on data-driven approaches, more importance is on how you can put things more on the server side, protect the data on the server side, and have the client side just do the rendering part and all of that. And for all of them, it's very important to split them into different modules and have the data pass between those modules instead of having one monolithic structure. Now, again, few theoretical part before we go into more interesting part of looking at a game engine and how it works and all of that. So some very common design patterns which are used in games, which kind of, there are multiple game design patterns which you can use, but some design patterns which like are used every day for any game developer that is there in my company or any company that is there. Factory pattern. Now, I'll give you an example of factory pattern. Let's say a game that you might have played, a game called Angry Birds. I'm hoping all of you would have played a game like Angry Birds. Now, let's say in an Angry Bird, there are different types of birds, right? Different colors of birds. But all those birds typically have certain common features as well, where you are pulling the bird from a catapult, the bird is flying up, and eventually the bird is going to land on those pigs or those bricks and it will fall. So what you do in a situation like this is you are going to create a factory pattern for this. What would a factory pattern do? A factory pattern would basically producing all these different kinds of birds. You are going to just tell the factory pattern is, give me a red bird, and the factory pattern would give you a red bird. Give me a yellow bird, and the factory pattern would give you a yellow bird. Now, let's say the factory pattern, if you go into more advanced formation of the factory pattern, you can even send them configuration. You can tell them, okay, give me a red bird which weighs 100 grams and which has a velocity of 20 meters per second. So the factory pattern's responsibility is to give you that bird. Your functionality code will be separate, but your factory pattern's main objective is to produce those different kind of birds. So it makes the code very, very readable, and it makes the code very useful as well. And same thing for all these patterns. There are multiple examples. The observer pattern, let's say, in a typical case in IT, it would be probably on a button press where you're listening to something. In a game, an observer pattern is structured in a different way. I'll give you an example. Now, let's say you have a game like Candy Crush, okay? And in a Candy Crush, what happens or BGL, whichever game you're popular with, as the candies line up against one another, then they are going to like give you points because they're going to break. They're going to have some sound effects, some VFX, and the score is going to get added, right? All these 5-6 things are going to get added. So if you're not using something like observer pattern, what would you do? You are going to write if a certain condition, if tiles match, then do this, then do this, then do this, and you're going to create a ladder of all these instructions, which will work. Again, I'm saying this will work. But What happens if there are 20 things that you need to do when a certain event happens? Then your code is going to get really, really messy because you're going to write all these if conditions and this 20 instructions below that if condition, and if doesn't happen, again else condition, and again else if. It becomes really bad. What would happen ideally is this scoring mechanism, this VFX mechanism, this sound effects will all listen to that event of that tile matching. And when the tile is matched, they'll automatically trigger themselves. So you don't have to write this complicated if conditions and else conditions and all of that. Right? So that's how you would use an observer pattern in a game. And I can give you an example of all these patterns. Maybe later on after this, you can connect with me and I can give you examples of all these patterns of state and singleton and command pattern and all of that. If I go in detail, I don't think we'll finish on time. Now, okay. Now, some of the common game engines that we have in our world is Unity 3D, probably the most common one because it's quite easy to pick up and quite easy to code. C# is again a language which programmers prefer because it's quite easy. It's not very complicated. There are no pointers, no references, so it's easy to manage. And almost most of the mobile games, Android, iOS, would be made in Unity 3D. Then you have Unreal Engine 4 and Unreal Engine 5, which I think are primarily used for PC and consoles. Yes, it can still be used to make mobile games. Why not? But you have to be careful while using Unreal Engine on mobile, because it can get a bit heavy. But yes, Unreal Engine definitely is an engine which uses C++, a language which many programmers are not very comfortable with because it has pointers and references and it sounds complicated, whether it's not. Then you have custom engines where you could write your own engine in Java, you can write your own engine in Objective-C, or even JavaScript. Right now, with this whole Web3 and NFTs and everything coming up, there's a huge focus on web games. And when you're creating a web game, basically then you can create stuff on JavaScript. And some of the engines for JavaScript would be 3.js, Phaser, and all of those kind of stuff. Okay, now how to decide on the game backend and the infrastructure. Now this is something again people forget, that games also would have a backend. Almost every game, PC game, console game, mobile game would definitely have certain backends and they would have an infrastructure as well. So when it's a backend, typically what would happen is the game would have either a Node JavaScript, like probably using some kind of framework like Sails or something like that, or PHP or Java or C++ or C#. How will you decide which backend language? Again, it comes down to two things in my opinion. One would be your strength, nothing else apart from your strength. And the second thing would be the cost. Maybe it is cheaper to write Java code on a Linux machine than writing .NET code on Windows when you host it. So it maybe cost is one consideration, but mostly your strength. And Java would probably be a backend which most mobile games would use, which are large games, because it's there for a long time. It has a lot of advantages and all of that. So these are the backend engines, and infrastructure is again an important part which is overlooked mostly as a game developer, is where would you host your backend. Now the main purpose of your backend, remember, is all the logic. The business logic cannot be on the front end because it will get hacked. If you write a logic of how a player will progress or how a level will be progressed on the front end, people are going to hack your code and add stuff in that and basically excuse me, mess up your leaderboard. So all your business logic still has to be on your backend. Nothing changes there. Like in IT also, in a proper IT, all your business logic will be on the backend. Even in games, your backend will have your business core logic. The front end would have your rendering logics and your basic movement logics. And infrastructure, again, AWS, GCP, this is Google Cloud Platform, Azure, and Firebase would be your common platforms of your choice that you would use. Right. Now, before I get into how to decide on a budget, let me share my screen. Okay. I hope my screen is visible. Okay, my screen is visible. Brilliant. Okay. So this is basically an example, like I'm open up an editor. This is an Unreal Engine. Unity would be similar with few things here and there, but this is how a game engine looks like. This is the front end side of a game engine, like where you would have your editors for placing different characters, which is known as your actor characters. I'll not get into those details right now. There are different properties of different parts. There are your different kind of props which you can add in your game, and then you would have your C++ classes which you can add. So let me, 1 second, just a second, I think if I share my screen, it will be better. Right, so if I press the play button, you can see that I have a character which moves around in the scene. Okay. I hope again this is visible. Just 1 second. You could all tell me the game was visible as well when I played it. Was the game visible when I played it? Oh, great. Great. Okay, I'll play it again. So if you observe, see, this is a character. The character is basically walking. It's running. Okay, I can move the camera around my character. I can jump around. I can even move on this platforms, and I can jump from one platform to another. I can go near this cube. I can go near this lovely Professional University cube and all of that, right? And let me go towards this cube once. This is reacting to physics. So I can move this cube around and kick the cube around and all of that, right? Now, so all that part, what you saw is basically what happens when you enter all your 3D objects, you enter all your code, you enter all your physics and everything, and you get a game out of it. You write your logic. Now, same logic, you saw the character moving, right? Now back to my slide. When the character is moving, right now the character is running. The character in the future can also crouch. The character in the future can also climb. The character in the future it's already jumping. The character in the future can do can strafe, can do all this mechanism. Now imagine there are so many mechanisms that we have for the character movement. If all these movements was just crammed together in one player script, then your code will never be scalable. Right now, basically, because if I have a movement script, and the movement script basically handles all the movement of the character, my code is extendable. Like, let's say if my game is released, after my game is released, let's say after users play the game, they said, okay, we like the game, but it would be cool if the character can also walk slowly when it's holding a gun. I don't have a walk. If you observe, I don't have a walk. Even if I press the W button, the character is running. So what if the users say that my character wants to walk as well? If you have a movement script which does handle movement, you just need to update your movement script, add a mechanism for walk, and release the game. Testing is super simple. Unit testing is super simple because only one code is modified. And that is the whole concept of a single ownership. That movement script is only handling movement. It is not handling input because input is not changed for me. Nothing is changed. My sound effects class is not changed. My VFX is not changed. My game logic has not changed. Just my movement has changed. Just I have to add a separate function called walk. Now, yes, in the future, when the game becomes even more complicated, even that walk, run can also be separate out into its own class as well. But okay, that's very, very advanced stuff. But at this very basic find of a game, the movement script is the only script that changes, and that is the whole point of your code basically split into different sections, right? I'll come back to this engine again after 10-15 minutes after I finish the slide to show you something else. But let us go back to the slides. I hope that was clear, right? And what, like from a game, why you need to split out a code into its own individual block mechanism rather than cramping all into one code, right? Now coming to the whole concept of deciding on the art budget. Now what I showed you there was a 3D game, right? Character was moving, that was in 3D. Now, if it's a 2D game, there are a lot of, when I see 2D, it just means two-dimensional, 3D, three-dimensional, just so that there is no confusion. Now 2D, we have to understand the resolution. Again, a problem that happens is if you're working with a team where it's 2D artists and programmers, you can, or you are working alone and you're downloading all these assets, you can download all high quality like 2K, 4K assets and all of that, and the game will look good, but as the game increases in size, the game may not run well in all machines. Is because you have now exceeded your resolution budget. It will run slow on slower machines. If all your game textures are all 4K quality, and let's say a user who is using a normal, when I say normal, the decent laptop, 8 GB RAM, that person may not be able to play the game completely well because the rendering required to run the game at 4K resolution may not be enough. Sorry, maybe too much, not enough, maybe too much. So you have to think about your audience. Do you want your game only to be played by people having 64 GB RAM or 32 GB RAM, or a wider audience? And if it's a wider audience, then comes two challenges. A, you do not want the game to look bad. You still want the game to look good, but you still want the game to be played by everybody. So you need to have that balance. You need to create a benchmark of what is my maximum resolution I'll use for my textures. Maybe it's 1p, like 1080, and that is good enough for most cases. Sometimes what you need to decide is, okay, my main character is going to use 2K textures, but remaining everything in the environment which are not that important can use 1K texture. That's a decision again you need to take as an architectural level. So when I say game architecture, it doesn't just mean code. Because that's why I didn't say game code architecture, right? These are all architectural decisions as a programmer you need to take, because ultimately you are the one that's going to press the build button and it will build the game. So you need to decide that, okay, what will be high resolution, what will be relatively lower resolution. Again, another concept, I'll switch back and you will notice that the character, basically the 3D model, is a high definition. What you can do in your game also, have 3 versions of that models, which PUBG uses, which almost every game uses. Those are called level of details, or LOD. I'll again paste it in the chat so that everybody follows. Why can't I do this? It's called level of detail. Now, what is level of detail? It means you have different versions of your 3D model. So, somebody raised their hand. Okay, one second. Is that something I need to ask? Okay, I'll continue, and then probably Dr. Ajay, you can tell me how I answer that. So basically, what you would do is, if you have different level of detail, then based on the architecture of the user's machine, either it's a PC machine or it's a mobile and everything else, you can switch between those models. So if the person has a really high-end mobile or a high-end PC, you can use the highest definition of model because that machine can use it. If basically the user machine is not as good, then you can switch to a lower definition model, which PUBG uses. That's why it can run on lower mobiles as well, and it looks good on the slower 2 GB mobiles as well, because it's switching between those models. That's one of the way to get performance, right? Second thing you would understand for a 3D game is basically what is the total number of triangles. Let me again switch back for a second just to show you something. I hope my screen is sharing again. It should be. Okay, let me run the game again. If I run the game, as you see, the character is moving and so forth. If I press F1, now you will see this entire game is made up of these tiny, tiny triangles, right? if I'm moving, of course the game works. If I'm moving on the pledge, if I go back to the stuff, you will see this. So these are all in the game engine made up of triangles. Every model is basically a triangle. All this cubes and stuff, they are all made up of triangles. So small triangles, large triangles, and so forth. Now, so when I say you need to think of the maximum triangle count, that is the triangle count that you need to think of in your game engine. Remember this way, that the larger number of triangle count of a particular model, the higher definition of that model. But it will take equally long time for your CPU and GPU to render those triangles. So it's a balance. You need to find the benchmark for your game, and you need to tell that to your artist or to your designer, this is the benchmark. A programmer only will tell that. How will the programmer decide that? The programmer will just put in multiple models with different triangle count and basically understand at what point the frame rate is dropping. At the point that your frame rate drops, if you're targeting 60 frames per second, if your frame rate drops from 60 to 59 or 58, you know you have reached your budget. And that is the maximum triangle count that you can have for a game. Roughly, it will still change based on shaders and textures and all of that, but you will get a rough idea. And then you can tell your artist, okay, this is the maximum triangle count I can have for a scene, which means this is the maximum triangle count I can have for a particular model. And that is how you decide on the budget. Okay, 1 second, let me see something. I'm still not sure how to answer those questions. Okay, I got it. Okay, it's a good question. It's again a fundamental question. Why specific reason for triangle? Why not any other geometric shape? Is basically when you go into graphics programming, everything eventually is broken down into the most primitive and the simplest shape, which is a closed figure. So for you to draw a closed figure, the minimum number of sides it will take is 3. 4 would be a square, which is the next simplest shape, right? The other shapes, if you take a hexagon, this is 6, and pentagon and so forth. So the simplest, most reduced form would be a triangle. For something to be forming a closed shape, that's why a triangle. That's the reason. That is nothing to do with the game engine. That is something to do with fundamentals of graphics programming. That is, everything eventually has to be broken down into its most primitive shape, right? Okay, let's move on to the next lesson, and then we'll move back again to our game engine and look at few things. Is something known as a draw call budget. This is very important concept again. Now, what is a draw call budget? Is again let me share my screen once again. Okay, again, let's say if I'm running this game, okay, and as I'm running this game, I am pressing F3. Okay, so you will notice few things. Okay, if you notice the character is made up of multiple small triangles, because as I said, my character is my main focus of my game. So that's why I need a really high definition model for my character, right? Because at any given point of time, no matter where you are in your geometry, you will always see the character, right? Now, because of this, what happens is there's something known as frames per second in your game. Now, this frames per second in your game determines how smoothly your game will run, because your frames per second is how many frames that your GPU requires to draw something on the screen. That is, like, by definition, that is what frames mean. So the longer it takes for your GPU or your graphics card to draw something on the screen, the slower your game will run, right? That is the concept. Now, so that is why if you have basically a lower end graphics card, it will take much longer for something to draw something on the screen. And when I say draw call, it means if you are having a game and to draw each triangles or to draw each things, the GPU has to work a lot harder. You are not going to get your desired frames per second. Now, again, for PC, the graphics card is really powerful, and so even if your game has 500 to 1000 draw calls, and draw calls must not be confused with triangle count. Draw call means to draw an entire thing. So the entire model will be using, let's say, 4 or 5 draw calls. That is dependent on how many materials there are around the character, along with the triangles. That's a subject we'll look at probably after this when we switch back. So let's say the character takes 10 draw calls. The cube takes 10 draw calls to render the entire cube, not just part of the cube, the entire cube. Like that, in a scene, if you have 500 draw calls, a PC will be quite powerful enough to still give you 60 frames per second. But a mobile won't be. So for mobile, the draw call limit should be somewhere in 90 to 150 to get the desired result. And now you see the problem. Let's say you have created a PC game which is very good and it runs nicely, and you have a draw call of 450. Now, if you have to optimize for a mobile, you have to get it down from 450 to 150. That is not a very easy task. So you have to think of optimizations from a very early stage. For consoles, people think like a PS5 and Series X, you can again not optimize and get away with it. It's not true. A PS5 also, the limit would be somewhere around 250. Of course, way more than a mobile. In PS5, okay, you can get away with 350 as well because PS5 is quite powerful, but not like a PC. PC, you can even get 800 draw calls and get 60 frames per second. No issues. Okay, so let's switch back again. I will go into more stuff. Okay, now, okay, as we are moving the character, okay, this character that we are moving, we are moving the character. There are multiple things happening in the game as well. You see the character has a shadow as well. This shadow is also something that is dependent on the light, which is also going to add to your draw call limit, which is also going to decide how you're going to run your game.
So we are not able to see your shared screen. We are only able to see the document code example slide, but not the game part. You can discuss.
Never or just now?
No, just now, just now.
Okay, 1 second. Let me know if you can see it.
Yeah, now it's not yet, sir. Yeah, now it's clear.
Now it's visible.
Okay, good. So as I said, okay, let me. This screen is also visible, right? When I'm playing the game.
Yes.
Yes, sir.
Okay.
Yes, sir.
So let's see. So okay. So let's say when I am on this ledge, it has a shadow. Okay, and there are also cell shadowing going on and all of that. So this is also dependent on your draw call limit, and your GPU budget will also depend. And these are decisions you need to take architecturally. Like, will my game have shadow or not? Right? Because the shadows, if you notice, they are not triangle count. There is no triangle count for the shadow. The shadow is entirely generated based on the model. So you are writing some code, or there is some inbuilt code that is taking the model and then doing something very advanced known as stencil buffer and stuff to create the shadow. So those are decisions you need to take. Now let's get into something interesting. Okay, let's say that okay, this is a cube. Okay, this lovely university cube is there. Now it's not moving. That's because it has no physics to it. Now, some game engines like Unity, Unreal will have some basic physics that is inbuilt. Okay. But more often than not, you have to add your own physics. So for the time being, I'm going to just add a very basic physics to it so that my idea is I can push this cube to the edge of the screen. Okay, this lovely university cube. So the way I would do that in a game engine is I would select it, and as simple as I'll go to detail, go to physics, I'll just simulate physics and probably give it some mass, like, and see if that works. So now, if I go and move, oh, it's not moving. Okay, it's moving. Maybe it's too heavy. I give 1,000. So let's. If you notice, it has moved. Okay, let me just use it to 500. Okay, so much better. I can move the cube around. Maybe I can now jump on that cube as well. Let me try. So these are all physics happening by default. Yes. And can you change the physics? Yes. So we are going to also write a bit of code. Like I've written a small bit of code, and then we'll see what happens when we write code to kind of do stuff as well inside a game engine. Right? So the way this is C++. Okay. So selecting. Okay. Is my Visual Studio script also visible on screen? Somebody can confirm.
Yes, sir.
Yes, sir.
Yes, sir.
Okay. Okay. So let's say again very basic. I'll not go into the structure of Unreal Engine. Probably again it will not finish. So let's say I just do a very basic stuff. I'll explain the code as well. But as a programmer, it should be very simple. All I'm doing is taking the location of a certain object and basically just trying to add some sine curve to that so that it changes with time. So what I want as a behavior is basically any kind of object that this script attaches itself to should basically go up and down like a sine curve. I think all of you are aware of how a sine curve works. So we'll just take some kind of actual location, we'll add that to the delta height and then just change it. So let me see if that works first and then we'll go and see. So let me. My code has compiled. Let's see, run it. Okay, see now my code is attached to that cube and the cube basically keeps on going up in the air, right? So that is not physics that Unreal Engine has given me. That is physics that I added in the game with that piece of code. Is that visible? That cube visible which is going up?
Yes.
Okay.
Yes.
So that is basically, and how do you do that? Basically, this is the cube, and I've attached that script which is there, which is this moving platform script to that cube. Okay. So basically, if I attach that script to any other object, it should also move in the same kind of way, basically. Right? If I attach something, I'll not attach the moving platform here because it's quite heavy, but anything that I want to have an event form, I'll just write a C++ script, and the script again, if I open, it's fairly simple. What happens in this script is basically taking the characters. Actor is basically any object in your game engine would be called an actor. So I would take the actor's location, and based on the actor's location, I'm just adding some kind of value to it and then creating this kind of script to that. And that is basically what's happening in this world. Is this these are the different properties of the cube, and this is moving. Now what happens, let's say, if I go into this cube's physics, if you see, just compare, okay? Over here, if you see, there's an option for simulating the physics, okay? So I have simulated the physics, and basically it has the linear damping and all of those going on, and so it moves. If I go to the other cube and I go to physics, basically I have kind of tried to override the inbuilt functions of that cube with our own physics. So we are not using the physics basically which is given by automatically Unreal Engine. Now let's say I try to do something. Let's say, okay, live coding. Let's say I add some barrel to this. Okay. Now let's say okay, and now try to play the game. You see, because I've added the barrel also onto the same script, the barrel and the cube both move in the same way, right? So the script doesn't change for me. What changes for me is basically I can attach different objects now. So if let's say I don't want the cube over there, uh, just so I can attach different objects as well, right? And let's say I have this barrel. So all three are rising in the same speed, in the same way, because all the three are using the same kind of script, which we have written just for an object to go up. Okay, now what happened before and what happened later is just a construction. So I can actually now, if I want to, because you see the moving platform is a C++ script, and that script is getting attached to all the objects. So I can basically create my own kind of funky thing as well. And now basically if I have to test out a certain monster or something like that, I can basically use that as a dummy way, where basically the barrel could be part of a machinery which is shooting some balls out or shooting some guns, right? This could basically this barrel basically could be my way of, if I have to place it, I can place it down. And that happens. So you can basically in a game engine just attach script to certain objects and they would basically have those behavior then on those objects attached, right? I hope that is clear, right? Now the second part would be like this game object engine wise. We'll go into how the script, you can split it out into separate parts. But let's say let me attach any material just so that you can get an idea of how material looks like. So okay, let it be anything for now. That will take too much. Okay. So you can now change the materials as well on the object just so that it looks pretty. And of course, this is something a programmer won't do. But if you notice the material that is used on that object, that is where the budget comes in, which I was telling. Like what will be the total resolution of this, right? If I click this and I open this up, it opens in a different editor. It will tell me what is the color and what is the texture that is used. Now, this is where basically you need to tell your artist is what is the resolution that you're going to use for this. What is the maximum amount of texture quality? Is it 1K? Is it 2K? And all of that. So if I look at the property of that, let's say it will be there somewhere in the Explorer. It's saved as a UAsset file. right? This is game engine's way of decrypting the asset so that it cannot be hacked. You don't have to do any kind of decryption or encryption. It does it on its own, where basically it is encrypted and you cannot. But eventually, let's say this LPU image, for example, I just took it from the internet, right? So if I open it up, this will have a certain file location. And so it is a JPEG, it is dimension, if you can notice in the screen, I don't know how large it is showing, but it's 300 into 168, which is very, very small. And to be fair, I did not require a 2K or a 4K image to be put on that cube. And a small image like a 300 by 168 was itself enough. So this is again architecturally decisions that you need to take as to what will be higher resolution, what will be lower resolution. For example, this barrel texture is a higher resolution because you can see from the detailing that is there on all of that. Right? Okay, now coming to the last part probably by which we will finish is how would you create classes over here? Let's say you are creating a C++ class. In Unreal, you would always select what is your base class from where it is deriving. And there are different objects from where you can select your base class, but let's say I select a pawn class and I create a class. Okay, so this class is then created for me. There's a header file created, and then there's a header file created and a C++ file created. This is where basically, and you see over here, it already, if you understand how virtual functions work and what override means, we understand this command as well. So when you're writing this child class, it is deriving from this pawn class. So all the properties of the pawn class are already there. And your child class will basically, if you want, you can override this tick functions and the input functions as well, what you want to do. So all these classes has some part of code already pre-built for you, like begin, play, tick, and stuff. And if you notice the moving platform class that we wrote, we just added a bit of code inside the tick. Ideally, you would not write it here, right? What you do is you have your own function, and inside the function, basically, you would basically write this piece of code. You will not write it directly in the tick. So if I'm creating a game like this, where the character is moving, few things that I would always do is, let's say, let me write it in the header, right? Is things like, I would have an input class which would just handle inputs. So where would I write the input class? If you notice, this already has a class called setup input component. So this could be like the class which is basically the player script, but I will not write any code of player input in this class. I will basically make an object of this input class and have that object inside my input component, and basically whatever input is got, I just pass it on to that class, that it's your responsibility, you handle how you're going to do with the inputs, left, right, up, down, button, and all of that. Now, what is the biggest advantage, I'll tell you this, of having an input class? Apart from that, there are multiple key presses. Mobile, PC, console, all would have different input mechanism. A mobile would have touch. A PC would have keyboard mouse. A console would have a game controller. So are you going to write different game logic for every time your game is going to get transferred from one engine, from one platform to another? No. The idea is that my input class typically would again have its own child classes. One for mobile, one for PC, and one for console. So when my C++ class would call an object to my input class, based on the architecture, the input class would then call its child class. Either it will call the mobile class or the PC class or the console class. Again, what is the advantage for that? Let's say your game is released in all platforms altogether, but there is only bug coming from your mobile game. Your developer can only look at the input class, and not just the input class, your developer can only look at the mobile class, which is the derived class of the input class. So only again one class the developer has to look at, not again an entire code base. That will be madness. So it's very important to split your code into smaller chunks of code, because it will be easy for you later part of your life in the game cycle. Because initially it will not be mattering too much because the game is small and all of that. But as your product keeps on growing and your product becomes really large, 2-3 years, it will be a nightmare. So sometimes when you're writing your code and you're doing the splits, your mobile class may just be a skeleton class with no code inside. That is fine. It still means that you have thought about that class. It still means that in the future when you write your mobile class, it will just be derived from your input class. It is fine if there is no code added, but at least you know where each code will go. Right? Same for the movement class. Right now, again in moving platform, I'm calling it from my tick function. Here what would happen is, inside my tick function, what's a tick function? Tick function is basically a update function which happens every frame. Okay, it's called written on top. It's called every frame. So at every frame, you see this is always running. This is always called. So it is not event based, like you press a button and this function is called, not like that. This function is always called, right? So your movement class, actually, you can write it again in your tick function, but may not be a very good idea. Why? Because your character may not need to move as well if I'm not pressing any input, right? So if my character, if basically I'm doing nothing, why should my movement class functions be called, or why should I check for movement? Because I'm not pressing any button, I'm not pressing any touch, I'm not pressing any controller keyboards, right? So what again would happen typically in a game engine is, your input class would basically call your movement class. So that avoids your movement class to be called every single frame. Here it is different. Here basically, irrespective of my input, I still want my platform to go up. That is why it is going up, irrespective of whether I press a button or not, right? But here what happens is, if it's a character which is moving, I would want my input first to register it based on its mobile, PC or console, and then my input class would then tell my movement class, please move. Now what again in the movement class, you could have multiple things like walk, run, jump, strafe, climb, so on and so forth. But also, what if your game has something called a power-up, whereas, like, I don't know if my screen is visible. Let me increase the screen. So what is a power-up? Let's say in my game design, I have a concept of only when I pick up an object. This is the game designer's user story, that if a user picks up an object, then have the jump function. Right? So your jump is basically not always present. So if the user presses space, it will not jump, only when a pickup is happening. So what did we learn that we can use here is, we can use the observer pattern here. So my jump function is going to listen to whether I am picking up a power up or not. And every time I pick up a power up, based on that observer design pattern, it is then going to trigger my jump function. And that is how you build up your game architecture slowly and surely. And because they are all separated out into different functions and separated out into their own classes with their own responsibility, it will become way more easy when you eventually debug your code, when you extend your code for scalability and all of that. Right? So I think that much is what I wanted to cover in today's session. So if you want to ask some questions, I think Dr. Ajay, we can open the floor, right, for that.
Yeah, sure, sir.
Okay. So, if any questions, you can now go on asking me if there's something I can answer. Right. So, just another note: if after this session also you want to ask me stuff, I'm quite active on Instagram and LinkedIn. You can reach me there, no issues. You can direct message me, and if you want to ask some questions, or you can email to your professors and they can send me those questions and I can answer those questions as well, no issues.
Yeah, students. Any query? What I, Druhin sir, think, you explained this particular subject, the gaming, in a so simple, elusive manner that in fact I fall in love with it. being even with a non-technical background, but still in a so simple way you had explained the things.
Yeah, thank you.
Yeah, students, any query?
Fine. Still, many people are there. That's good.
Yeah, Shikha, Shivam, you can open your mic and have your queries.
May I ask a question for you, sir?
Yeah.
Like you are saying that there are so many types like software engineer, data analyst, and market manager. If someone wants to in this, like who was the individual owner of this game, so how it will do? How to do? Do you get my question?
Sorry, Dr. Ajay, can you translate that question?
What are you saying, sir? That what the things are being there into the English. So if it can be in the vernacular language, how they are going to do it, be it in Hindi or even any other languages?
Yeah, that is a big problem. There's a big challenge for that. What happens is there are certain YouTube channels which are trying to do that. I am also trying to do certain sessions which is in Hindi or in Bengali, which is my mother tongue. But it's very important question. That is something that I think all universities and us as content creators and game developers are also trying. Abhi kuch hai nahi zyada. If you look at Unreal's documentation or Unity's documentation, everything is in English. So I think someone has to take the initiative to kind of do this video tutorials in Hindi, so that, or any other vernacular language, so that it's more accessible. That's actually a very good point.
One more, Druhin sir, just as right now the mobile penetration, the network penetration in the rural India is increasing day by day. So I think that is also a, I would say, area in which the companies can work on. They can look for the opportunities in this area.
Yeah, absolutely. I think there are many companies which are also starting certain like skill courses which are in the vernacular languages, because what he mentioned is a very important point. Is most of it is in English, so we are also trying it. So another question has been asked.
Yeah.
These days, the major area of game development involves which platform or PC, I think PS, or I think it means PC. It's not like that. I think most developers would be on mobile because that's a larger mass market, but and then it would be PC and then it would be console. But I would say all the markets are equally important right now. Even in India, PC and console was not that popular in game development, but it is slowly rising. So if you want to do something very simple, I would still suggest do it on PC, because you just can create something really quickly and check on your machine. Mobile, it's slightly more tricky, and console is the trickiest or the most complex. All of them, so I'll follow. Okay, more questions. Future of game development in India is very bright. I think game development, when I started, as I said, very early 2003, it was very bad in India. But right now, people look at game development that it's a very stable industry. There is a lot of coding. There's a lot of artists involved. It's a big business. A lot of capital is coming in, which is helping as well. What we lack in India are publishers. So most of even we have made so many AAA games in our company, but there are no Indian publishers, or very few Indian publishers. Most of the game publishers are outside India. So that is changing as well. So I think for the next 10 years, 15 years, it's very, very bright, the game development scene in India. There's no question about that. There's a huge skill shortage. We are looking for game developers, game artists all the time. So it's a huge skill shortage right now in the market.
Druhin sir, one question from my side that for the students, that what are the skills they need to have to be a game developer?
Again, if you see, there are various aspects which I mentioned in the slide for different kind of stuff, but it's a very transferable skill, I believe. Like if you are a programmer, let's say you know Python, right, and you are very good in Python or you're good in Java, you can still transfer your skill to game development. You have to learn the Unreal Engine side of things, but the fundamentals of coding is not changing. Functions will not change from a Python to C++ or a C#. The concept of object-oriented not changing. So yeah, anybody can transfer their skills into game development. I think it will take 3 to 6 months, and you can transfer your skills.
Good.
Somebody asked, is high coding required for game development? Yes and no, depends on where you want to go. So if you are a very creative person, you can basically get into the industry as a game designer and learn the basics of game designing, and then you can switch from game designing to game development as well. That is no question. That's very easily doable. So game designing is probably the way where you get in to understand how a game is made. And then if you like programming, then get into game development and coding. If you don't like, then stay into game design. No issues.
One more question was there, sir. What are the basics of from where we can start as a beginner?
Which platform is best, or what is the basic? Okay.
Yeah.
What is basic where we can start? I think again depends. If you want to get in the industry as a programmer, first decide as to which language you want to start with, C#.net or C++. And then if it's C#.net, because it's slightly easier, then just open Unity Engine. Open Unity Engine, just write 4 or 5 functions. Like when you start programming, you write hello world, right? In a game development, our hello world is taking a cube and moving it. If you can move one cube, you can move everything in the eventually. So just download Unity Engine, and then Visual Studio will be there. Just write few code if you want to get into it as a game developer. If you want to get in as a game designer, there are multiple books that is there. One is there, the Theory of Fun, I think the book is called. Let me check. I think it's called The Theory of Fun. I messed up the name. A Theory of Fun. Yeah, that's the correct. A Theory of Fun. You are sharing all about team. If someone wants indie, how to do. Well, it's also indie. Nothing is, even if you are an indie developer, you cannot do the artwork yourself, right? It's impossible. Unless you are an artist and a sound engineer, then how would you do it? That's something that you need to learn, Shivam. Then what you can do is you either have to pay an artist to give you all the artwork, or you basically need to buy assets from a different asset store. Like you can do the programming yourself and then buy all the artwork from different stores. Like if I share my screen again, 1 second, let me share my screen. Let me know when my screen is visible, Ajay.
Yeah, it's visible.
Okay, so if you look at Epic Games, so this is like a marketplace. So if you require art assets, there are a lot of free assets as well. So you can just go and download, let's say, a character from that free asset, or some kind of this character from the free asset, and start doing your stuff. If you want to, like, let's say I want to an environment, okay? So you can just go and search for environments, and then you will have this city environment that you can use. Okay, you have to pay this 7,000 rupees for this environment, but yes, that is one way where you can do it yourself without the requirement for an artist.
Students, there is one more thing which I would like to add here is that Druhin sir has also written one book for
Yeah,
the.
I'm also
There is
writing the second version of that book. That book
yeah,
is a bit outdated because I wrote it again long time back. In programming, everything becomes obsolete after 3 years. So I'm
yeah,
writing the second version of the book. So I recommend don't buy it yet. Let me write the second version soon. Let it be out, and then I'll tell you when to buy that book. That will be
yeah.
more up to date with the current trend, because the
Because the
C++
things are
standard is also
changing very fast.
yeah, technology always changes, right? It's always. Pile Paul asks which book. Okay, okay. There's a book I wrote. It's a very old book. It's been 6, 7 years now, so it's quite outdated now. I'm going to write a new book soon on game design and game programming. Then you can get that. And another thing that you can do is every now and then I have these podcasts with on my Instagram channel with other people from the game industry. So if you can sign into those podcasts as well, there are different things that you can listen to. Like somebody asked me recently that I'm very good in writing, right? I'm very good in writing Hindi and English. Can I join the game industry? And the answer is yes. There is absolutely a need for game journalism, which is missing. There is no good game journalist in the game industry. So it's again very new in India. So doesn't matter what your skill is. I think in the game development there is a skill that will match, right? Because now game engines are also used for simulation software for the army. Game engines are used for post production in movies. Game engines are used for therapeutic and mental health solutions in rehabilitation centers. So you have to just use the engine in certain way, so you can do that.
Yes, students. Any more questions? Because this is a platform where you can ask the questions from the expert.
I think they are not sure what to ask right now.
that is also one thing.
Either my,
yeah.
yeah, I think either my lecture was very boring and people went to sleep, or they don't know what to ask.
No. That is so. One more thing, just as you were telling us in the starting about the kind of people which are being required, the different post, I would say, the developer or the testing team. So I think in the future, maybe after a few days, we can have one session on the what are the career opportunities. As you were talking about the game journalism also, what are the career opportunities in a total gaming industry? Because right now, what the people think about that gaming is all about only coding, no more career is there. So, but by looking at yours one, the different perspective has come out.
Correct, absolutely. I think previously people used to think game development is all about animation. Now it has changed to game development is all about coding, but neither of them is true.
Yes.
It's like a very large team, very large team. There are lighting artists, there are VFX artists, there are texture artists, there are game journalists. So I can do that, and I might be visiting LPU as well in July or August. I think that's the plan. So
in that case, we can have one when you will be in the university. In that case, we can have one more session for our students.
Yeah, absolutely. I can do that. I don't know the date yet. I think Vaneet will tell me what's the date.
Yeah, sure. Accordingly, we can plan it, sir.
Absolutely, no problem.
So, it had been a wonderful session with Druhin sir, and the kind of very simple way sir has told us about the gaming industry and how to build the architecture. So earlier also, as I said, that even I fell in love with the gaming. Frankly speaking, I have not been into gaming, but by looking at how things were moving and how he was explaining the thing, this shows the kind of teaching Druhin sir is providing to the students, that they fall in love with the course also. So here I would like to thank Druhin sir for sparing his valuable time from his very busy schedule. On our call only,
You have
he has
5 minutes
agreed to
remaining.
take this time for our students. Sir, thanks a lot. I really appreciate it from the core of my heart that you had delivered a very, very insightful lecture for our students. And on the same, I would like to thank here our Senior Director, Ginny Ma'am, Manish Sir, Kulvinder Sir, our colleagues, as well as my dear students who had spared their time to attend this very, very knowledgeable session. Thank you, sir. Thanks a lot. Thank you,
so much.
students.
Thank
All
you,
of you are
students.
requested to fill up the feedback form also, right? So now with this, we will be ending this session. And as sir is also having some very busy assignment just after this lecture, and you are also having the lectures from 11 a.m. So I wish you all the best for today's work. Thank you. Thanks a lot. Thank you, sir.
Thank you. Bye.
Thank you.